Hey Opties! Today we're looking at distance and we're going to do some practice. So when we're finding the distance of a segment, we could use the Pythagorean Theorem or the distance formula. Let's go ahead and take a look at number 1. Number 1 says, if each unit on the map represents 1 foot, what is the actual distance from Gladys's to Anna's flower cart? Okay, so notice we have 3 points. And we have Gladys's, Anna's, and Rachel's. But we're only asked the distance between Gladys's to Anna's flower cart. So we're looking for this distance. We can see that Rachel's looks like it forms a 90-degree angle with Gladys's and Anna's. So it's going to be helpful if we want to use the Pythagorean Theorem, which is what I would probably use here. But I always prefer to use the Pythagorean Theorem when I'm thinking about it. So it works either way. Let's go ahead and find the point for Gladys's flower cart. So that looks like 3 and 4. So 3, 4. And Anna's is 1, 2, 3, 4. So negative 4. 1, 2, 3, 4. Negative 4. Okay, so let's look at Rachel's. It should be the x value of this one and the y value of this one. So it should be 3, negative 4. Let's count it just to be sure. 3, negative 4. Looks good. Okay, so let's figure out this distance between Anna's and Rachel's, which will be our A or B, one of our legs of our right triangle. Because this is a right angle because that's vertical line and this is a horizontal line. So the difference between the x's, that's a negative 4, so this chunk is 4. This is a 3, so that's 3, so 4, 5, 6, 7. So that's going to be a distance of 7, or a width of 7. From Gladys's to Rachel's, that's down 4, so this is 4. And that's up 4 right here to Gladys's from the x-axis, so 4 and 4 is 8. So those are our A and B values, and we want to find C. So let's substitute into the Pythagorean Theorem. A squared plus B squared is C squared. A is 8 or 7, it doesn't matter, plus 7 squared, and that equals C squared. 8 squared is 64. 7 squared is 49. And then we have C squared. So we have 60 and 50, which was 110. Plus a 3, so 113. And let's take the square root of both sides. So C, remember it's plus or minus technically, but because we're talking about distance, it's going to be the positive square root of 113. And as a decimal, it's about 10.630, and I just used a calculator to do that. If you wanted to use the distance formula, you would just use the points for Anna's and Gladys's. Let's take a look at number 2. The dimensions and shape of a rectangular soccer field are shown in the picture below. What is the approximate distance of a ball's path that is kicked diagonally from one corner of the field to the other? Now, this is guaranteed that you need to use the Pythagorean Theorem rather than the distance formula because there is no XY ordered pair for either of the endpoints of this segment. So we're going to find the distance of this segment here. And we're already given our width and our height. So we can go ahead and go straight to the Pythagorean Theorem. A squared plus B squared equals C squared. So A and B are 50 and 100. It doesn't matter the order. 50 squared plus 100 squared equals C squared. 50 squared is 2,500 or 2,500, and 100 squared is 10,000. I was like 4 zeros. Just gotta make sure I'm getting it right, and that equals C squared. So if you add these together, you've got 12,500, and that's C squared, and we're gonna take the square root of both sides. Again, it's positive because we're talking about distance. So C is the square root of 12,500, which is approximately, now we should have really said approximately equal to over here, because we're approximating, we don't have all that decimal. So that's approximately equal to, that's about 111.803. And we're actually given units here, meters. So that's that many meters. And we forgot to do the units over here on number 1. Let's fix that. So this is in feet. So remember, it says each unit on the map represents 1 foot. So that's going to be in feet. Don't forget units. Don't be like me. Don't forget units. Let's look at number 3. What is the length of the line segment whose endpoints are represented on the coordinate axes or axis by the points -3, -2, and 4, 1? Okay, since this doesn't give us a graph, this might lend itself a little bit better to the distance formula. I personally would always rather use the Pythagorean Theorem when I'm thinking about it, but again, they're really the same thing, so it doesn't really matter. But I will work this from the distance formula just to show you that some more. So the distance is the square root, and the square root comes from taking the square root of the c squared, of the difference of the x's, which is how you find either a or b, your width piece, squared, like your a squared, plus your b, which is going to be the difference of your y's, squared. So again, this is really the same thing as Pythagorean Theorem. Let's go ahead and label each point as x1, y1 or x2, y2. So -3, -2. Let's just call this the first point. It doesn't really matter. And we'll call 4, 1 our x2, y2. It is good to write this out like you're labeling it, because it helps you to not accidentally make a mistake. That's probably why I like to use Pythagorean Theorem more, because it's so much more visual in my opinion. Okay, so we have this big old square root. Let's do our x2, which is 4, minus our x1, which is -3. Now notice, you're subtracting whatever that x value is. So I wrote this minus sign because it's part of my formula way before I ever even looked at what my x1 was. Because if I didn't, I might just go ahead and write my -3, which is this point, or this coordinate, and then I might accidentally leave out this minus, and it would be 4 - 3 instead of 4 + 3. So be very careful. And then we've got plus y2, which is 1, minus, see, I'm writing that before I look at my y1, -2, which is good because it would mess up if I didn't have the minus there. Okay, let's continue with this formula by simplifying our parentheses. So we've got the square root. 4 minus -3 is 4 + 3, which is 7. So 7 squared. We can take away the parentheses now that we have simplified that. And then 1 minus -2 is the same thing as 1 + 2, which is 3. So 3 squared. And let's carry down our d for good notation. D is the square root of 7 squared, which is 49, plus 3 squared, which is 9. So D is the square root of 58, which is approximately equal to 7.616. Finally, let's take a look at number 4. Square ABCD has vertices -1, -2 for A, B is 5, 0, C is 3, 6, and D is -3, 4. What is the approximate length of a side of the square? Use the grid below if needed. Okay, so this one has lots of extra information. You really only need 2 points because to think about it, you need 2 points to find the length of a segment because a segment only has 2 endpoints. So you just have to decide what segment are you trying to find the length of. Well, if you're trying to find a side of the square, and the square is ABCD, all sides are congruent. All the sides are equal in measure. So you can either find AB, BC, CD, or DA. Now, how do I know this? It's because I know that if it's written ABCD, this is showing me what vertices are adjacent. So AB would be a non-diagonal segment. It would actually be a side of the square. So would BC because those letters are next to each other. So would CD. And wrapping back around, so would DA. So if you wanted to use the distance formula without having to graph anything, you could just think about it this way and pick 2 points that are adjacent to each other, one of these pairs, and then you could just use the distance formula. Let's go ahead and graph it just for the sake of doing it multiple ways to get a good view of it. So A is -1, -2. B is 5, 0. C is 3, 6, 1, 2, 3, 4, 5, 6. And D is -3, 4. 1, 2, 3, 4. Okay, so let's connect these to get a good look at our square. And we want to find one side of the square, and they're all in equal length. So let's just do DC because it's the top and it's just right there at you. It doesn't really matter. Again, doesn't matter, they're all equal length. So from D to C, let's just write those points out. 3, 6, and D is -3, 4. So the width would be the x value difference. So -3 and +3, that's going to be a 6. And the height is going to be 4 to 6, so that's 2. So here's the Pythagorean Theorem. C, which is going to be this guy, but let's go ahead and call it CD, just for good notation because there's already a point C. We don't want to get that confused. So 6 squared plus 2 squared, and that equals CD squared. So let's simplify. 6 squared is 36. 2 squared is 4. CD squared, still CD squared. 36 and 4 is 40. So CD is going to be the square root of 40. And that's going to be approximately equal to 6.325. And it doesn't tell us units, so we would just call this units. And over here in number 3, it also didn't tell us units, so we'll just say units. And I want to show you how to write the square root of 40 in simplest radical form instead of just a decimal. So that means we're going to take out all the squares that are in 40 because the square root of a square is just the number, right? The number that's the base. So let's take a look at 40 and we'll try to find any squares that are in there. So any factors that repeat twice. So let's take a look. We could have 4 and 10. And we already see we have a square because 4, that's 2 squared. So we have 2 2's. So we know we're going to be able to take out a 2 because what's the square root of 4? 2. And then 10 is 2 and 5. Okay, so let's rewrite the square root of 40 as 4 times 10. We know that this 10 is not going to break down any further and it doesn't break down into any squares. But we do know that the square root of 4 is 2, so we want to isolate that. That's the same thing as writing the square root of 4 times the square root of 10. And what's the square root of 4? It's just 2. So that's the same thing as 2 square roots of 10 units. So that's another way to write this answer. So 3 different ways: the square root of 40, 6.325 units, or 2 times the square root of 10 units, or 2 square roots of 10. That's another way to say it. All right, that's it for practice with distance. See y'all next time.